Hi, this video is to talk about testing hypothesis for the difference between two population proportions. Okay, so there's let me see here the application. This is the text preparation firm problem we had in the slides for the interval estimate for two population proportions. So I'm go back to this slide. This is confidence interval two population proportion. Confidence interval is the same as interval estimate for two population proportion. So these are the slides for building interval estimates. And I'm going to use the same problem, but now to test hypothesis. I'm just going back to the slides to take a look at the problem, okay? Because it's the same problem. So we have a text preparation firm. They have two offices, okay? Office number one, office number two. And we collect a sample of 250 forms that they filled out in the office one. In the office two, we collect 300 forms they filled out, and then if we have 35 of this 250 with error, and in this case 27 out of this 300 with error. So if we divide this number by this number, we get this proportion here of errors, and if we divide this number by this number, you get the proportion of errors here. So let's take a look here. Okay, so proportion of errors in the first office 0.14, proportion of errors in the second office is 0.09. The difference for the proportion in the two offices is 0.05. Okay, so I'm going back now to slides about hypothesis test. We want to test and determine if that difference of 0.05, this difference is really significant at 0.10 level of significance. The question is, can we conclude using a 0.10 level of significance that the error proportions differ? These two error proportions, they really differ. The difference is 0.05, but is it really different at 0.10 level of significance? That's the question here. So I'm going to follow my steps that I propose, and the first two steps is develop the null alternative and determine if it's a lower, upper, or two-tail test. So let me go to here. All right, so step number one, I have the null and the alternative hypothesis. I have the mean one and mean two. This is because they differ. It doesn't say one is higher than the other. So if this differ, that's how the alternative is. This is what I want to test. So I have to assume that they are equal. This is the same as saying that the null and the alternative, if I move the mu2 to the other side of the equation, I have mu1 minus mu2. This is a positive number, goes to the other side as negative. Is different than 0. Mu1 minus mu2 is equal to 0. Okay, so because of that, I know and answered the question in step number 2. That is a two-tailed test. Two-tailed test. Okay. Now I can go to step number 3. Step number 3 is establish the level of significance. The level of significance is 0.10. Because it's a two-tail, I have to divide this 0.10 by 2, which gives me 0.05. And then I have to, this is what the slides are saying. If two-tail, divide alpha by 2 and perform step 3.1, use as it is. So use as it is this, and 3.2 for the upper tail, 1 minus. So 1 minus 0.05 is equal to 0.95. Okay, so these are the numbers that I'm going to use to find the z critical in the two tails. Okay. So step number 4 is find the z critical. Okay, find the z critical. So I'm going to use Excel to show you how to find the z critical. So we have upper tail, the z critical in the upper tail, and the z critical in the lower tail. So the z critical is equal to norm dot s inverse, and the probability is this first probability here, this upper tail probability. This is, how can I know that this is the upper tail? Because remember the distribution 0.95, in the distribution, I have lower numbers here, bigger numbers here. So up to this point, I have 0.95 of the entire distribution. So what is left here is this 0.05. Okay, so this is the reason I know that this is the number that goes in the upper tail here, 0.95, close parenthesis, and then the z-critical in the upper tail is a positive number. So here's the z-critical, 1.64, and this is the critical region. Okay, so if my z-statistic is higher than 1.64, I reject the null hypothesis in the upper tail. In the lower tail, what I have is equal norm.s inverse open parentheses, and then the probability that goes here is 0.05. Okay, this is the reason I get those two. So the lower tail is negative 1.64. Which let me erase this. This is negative 1.64. Okay, and this is the critical region here, and this is the critical region. So, okay, I'm still waiting for it shows up on the screen because I do here on the iPad. It takes some time to get there. Okay, so what I was saying is that I have the critical region here, and this is a lower tail, and this is upper tail. Those are the critical regions. So if the z statistic is less than negative 1.64, or if it is higher than 164, then you reject the null hypothesis. Reject null if the z is higher than 1.64 or is smaller than negative 1.64. Okay, if z has a value in between these two numbers, then that's the fail to reject. Fail to reject the null hypothesis. Okay, so clarifying one more time, I think that you already know that. So okay, I did that. I found the z critical in the critical regions. That's the reason it's called critical value approach. Now I have to collect the sample data and compute this test statistic, and I need to compute the pooled estimator. So now I have to use those formulas here. First, compute the pooled estimator, then compute this, and then after compute this number here, I can compute the whole z value. So I have this on slides, so I'm not gonna do by hand. So here is, okay, you have the pooled estimator first, and then you get this p, plug in here, do this standard deviation of the proportion, and then after do that, you plug this number here at the bottom, and then you get the difference between the two offices. Remember that 0.05 divided by 0.0271, that's the z, 1.85. Okay, first step, pooled estimator, get the p for the pooled estimator and replace in this formula here, and then you get the standard deviation of the sample proportion, and then you compute the z. Okay, all right, so that's the z is 1.85. So let me go back to my, so let's put it here. Z stats is equal to 1.85. Wait, let's wait. 1.85. So is this number smaller than negative 1.64? No, it's not. Is it higher than 1.64? It is higher. So if it is higher, you reject the null hypothesis. So let me show you in another screen. Okay, again, we have the distribution. We found the z critical 1.64, negative 1.64, and if here in this region, reject the null hypothesis. Or if here, reject the null hypothesis. So I found 1.85. Where the 1.85 is here. That's higher than 1.64. So 1.85. Because of that, I reject the null. Okay? Then if I reject the null, that's what I'm doing here. Compare the z-statistic with the z-critical. If z is smaller or higher than z-critical, reject the null hypothesis. This is what I just did. So I can go back to my hypothesis and I can reject the null. If I reject the null, I can say that the two offices differ. Okay, let's wait. I have to wait. Okay, so what I was doing was I was scratching the null hypothesis and concluding in favor of the alternative hypothesis, which means that these two offices differ. Okay, so let me go back to the slides and go over the p-value approach. The p-value approach is here on slides. So this is the p-value approach. Develop the hypothesis, specify the level of significance. In this case, you specify, and then the third step is compute the value of the test statistic. We did 1.85. Now I have to find what is the p-value associated with this z value. So the p-value associated with this 1.85 is 0.0644, okay? And then because determined to reject, because p-value is smaller than 0.10, we reject the null hypothesis, the same thing, okay? So I just want to stress this point of computing the p-value. I want to go back and show you. So this step says, find the probability, the p-value of the z you found here, the z, which is 1.85. It's a two tails. So you find the p-value for the lower tail, you find the p-value for the upper tail. Let me do that on Excel. So the z is 1.85. So p-value, p upper, and p lower. Okay, so the find the p-value in 5.1. I'm gonna fold this equal norm dist s dist, this one 1. I'm sorry, I switched things here. So this one is for the lower tail. The upper tail is 1 minus, equal 1 minus this number. Now I choose the smallest value. This is the smallest value. And multiply by 2. Final p-value. 0.06. This is the same thing we have here, 0.06. Okay, so this is how you find it. And then because it's smaller than 0.10, you reject the null hypothesis and you conclude that the error rates differ between the two offices. Okay, so this is how you do by hand. In the next slides, do by hand using the data in the problem. In the next slide, I'm going to show you how to test the hypothesis test using the raw data in Excel.